All right, this should be a reminder from geometry, but we're going to run through how to do trig ratios again. So whenever you have it, it's got to be a right triangle. The longest side for any triangle is the hypotenuse, so make sure you remember that. And these are really the only two things you got to remember, adjacent and opposite. So whenever you set up these trig ratios, it's always going to be relative to either this angle or this other one that's not the right angle. So it won't be set up relative to the right angle ever. The only thing you really have to remember is if it's touching that angle, it's adjacent. If it's not touching it, if it's across from the angle, it's opposite. Because any angle you have, it's going to definitely touch the hypotenuse, and it's got to be touching one other side. So again, if it touches that side, it's adjacent. If it doesn't touch it, it's opposite. And then here are your ratios, sine, cosine, tangent. So the first one is sine, and that's going to be opposite over hypotenuse. Cosine, it's going to be adjacent over hypotenuse. And then tangent is going to be opposite over adjacent. So basically every combination of those two sides we can have. And just a couple things to keep in mind while you're doing these. It only works for right triangles. We will get into some other trig that works for most triangles or any other triangle, but for now, this stuff is just going to work on right triangles. And then the last thing to think about, and I'll come back to this, the sine and cosine ratios, they're like percents. They tell you what percent this side is of the hypotenuse and what percent of the hypotenuse this side is. So sine would say this opposite side is whatever percent of the hypotenuse. And we'll get into that when we see the actual numbers here in a moment. So rather than tell you to either do sine, cosine, and tangent, what I'm going to do is get you to solve for some sides here. And we'll go through all these ratios and a few algebra things to keep in mind with these examples I've got picked out for you. So let's figure out x first. Now what I do know is I've got a hypotenuse of 15. I've got an angle of 41. So first of all, let's get these sides labeled right. Relative to this angle, this is the side that's touching it, so that's the adjacent side. That's the side that's not touching it, so that's the opposite side. So if we set up any sine or cosine, really any of these, those are what we're going to need. So again, let's solve for x. Well, what I do know is that x is an adjacent side, and the only other thing I have is a hypotenuse. And if I've got an adjacent and a hypotenuse, that's going to be a cosine ratio. And you always take cosine of an angle. Theta is the variable you usually see represent an angle. So you have to take cosine of an angle. It works no other way. When you hit the button on your calculator, it's going to pull up some parentheses. So cosine of 41, because that's the angle I'm given, is x over 15. And from here, you just have to make sure you remember your algebra. So to solve for x, we've got 15 on the bottom of the fraction, so multiply both sides by 15 and get rid of it. And then we'll put this in our calculator. When you go to your calculator to get these, first of all, go to mode, and you need to make sure we are in degree mode. You've got radians and degrees. If you're in radian mode, it's going to mess everything up. Make sure you're in degrees. And we are going to pretty much operate in degrees for quite a while. Eventually we'll get into radians, but for a good while we'll be in degrees. So we're trying to figure out what 15 cosine 41 is. So 15 times cosine 41. And I'm going to recommend you round to 2 decimal places on all of these. So 11.32 is going to be good enough. So there we go, 11.32. I want to come back to that percent idea quickly. Well, let me say x equals. So 11 out of 15, that's a little more than 2/3, probably around 70% or close to it. So I want to show you that. The cosine of 41 should be around 2/3, somewhere around 70%. So let's do that just to see. Cosine 41 equals 0.75. We've got 75%. So that tells me that if I have a cosine of 41, the adjacent side is 75% of the hypotenuse. All right, let's find y. So in this case, relative to the angle, you've got an opposite side. And you also know this hypotenuse. You could set up something else using this 11.32. I don't recommend it because this side was rounded, so that's going to make this answer rounded even more. You're better off to stick with the side that was given when you set up your math. So opposite and hypotenuse is going to be a sine ratio. Sine of 41 will be y over 15. And same algebra, multiply by 15 on both sides. So 15 sine 41. And that's going to be 9.84. So 9.84, that's close to 2/3 of 15. That's a little less, so probably somewhere in the neighborhood of 60, 65%. The opposite side, if we have a 41-degree angle, opposite side's about 60, 65% of the hypotenuse. So just to reiterate that point, sine of 41, I'm looking for about 0.6, 0.65. So there we go. Rounds to 0.66, so right around 2/3. On this one, I want to give you a couple scenarios that test your algebra a little bit more. And also, we want to make sure we do a tangent ratio here, so be on alert for that. Well, we've got a 35-degree angle, so relative to this angle, actually, let's start here. The hypotenuse is always the longest side. That's a really easy one. It should be the easy one to get first. All right, so the side touching 35 is x. That's the adjacent, which means that 3 is going to be the opposite. And it's not touching 35, so it's definitely opposite. It's definitely a right triangle, so tricks, the sine, cosine, tangent, they'll work here. All right, let's set up a ratio. Let's go for x first. Well, x is an adjacent, so I've got to be using either cosine or tangent. The other side I do know is the opposite, so I've got to use a tangent here. Tangent of an angle, it's always of an angle, is opposite over adjacent. Those are the two sides I've got. That's what I've got to go with here. So tangent of 35 is 3 over x. And I'm doing something a little bit challenging here. I'm putting x in the denominator. So a lot of students set proportions to solve these, and that's fine. You can always put anything you want over 1, cross multiply. I always recommend, if you don't understand why cross multiplication works, don't do it, because you can really mess stuff up by just cross multiplying any old time, even when you're not supposed to. So there's only one specific time it happens, and that's when you have a proportion, which is one fraction equals another. You don't ever do cross multiplication any other time, and I've seen it used in so many bizarre ways. So if you don't understand why it's working, just don't do it. So what we can do, and what we always want to do to get rid of a fraction, is multiply by the denominator. So we can multiply by x on both sides. That's okay. X is truly a number, so it behaves just like any other number. We multiply by 15 on the other two. That was fine. Once you get here, well, we want x by itself. So x tangent 35 is 3. Well, I'm going to need to divide out that tangent. And that should do it. So 3 divided by tangent of 35. I'm going to put that in parentheses just to be sure I don't mess anything up. Give it some extra parentheses because it's, remember, you have to take tangent of something, so it opens parentheses for you. So 4.28. Okay, and that is our x value. So now we need to find y. All right, well, y is the hypotenuse. I want to continue with the number I was given in the beginning. This is going to be rounded a little bit, so I really don't want to use it to solve anything else. So if I've got an opposite and hypotenuse, that's going to be a sine ratio. So sine of 35 is going to be opposite over hypotenuse, so 3 over y. And give me another situation where you've got to multiply by this variable on the bottom on both sides. And when we do that, then y sine 35 is 3. So Now we've got to divide by sine 35, similar algebra to what you just did. And that's going to give us our answer. So y is 3 divided by sine 35. Let's see if it works. Probably should put an extra parenthesis there, but it seems to be about right. So 5.23. And there you go. So there's your x and your y value.